The objective of this video is to get you to know where to access and how to run optimized generative AI and large language models on the Intel Gaudi accelerator using the Hugging Face Optimum Habana library. And we'll accomplish this by showing first an introduction to Gaudi 2 and our model references where you can access all these models. We'll talk about the Optimum Habana library and its optimized models and tasks, and then show you a real live example of training and inference using the T5 model for summarization. So first, let's talk about the Gaudi accelerator itself. We remember that the Gaudi AI accelerator is architected from the ground up for deep learning training and inference at scale. It has 96 gigabytes of onboard HBM2E memory, 24 integrated 100 gigabit Ethernet ports for scalability across nodes and pods, and 24 tensor processing cores. So it's a purpose-built AI accelerator. We pair this with the Synapse AI software suite, which is dedicated for both training and inference and supports PyTorch and TensorFlow. We have this very easy interface to bring your PyTorch model or TensorFlow model, integrating with our framework integration layer and lowering that to our graph compiler, our communication libraries and drivers, as well as using our rich set of kernel libraries. So it makes it very easy to integrate your models with the software stack. We also support the ability for you as a customer to write your own custom kernels as needed. The most important part here about the software suite, the Synapse AI suite, is the fact that we offer full PyTorch and TensorFlow Docker images, which contain the entire software suite that you need to get started very quickly. So simply download a Docker image and you could be up and running in just a few minutes. So to get started running, we look at today the evolution of large generative AI and large language models. We see we're on an evolution to a path to 1 trillion parameters. And these model sizes are only going to get larger. So current hardware solutions no longer can hold an entire model for efficient performance. So we need advanced techniques where we'll split a large data set across multiple accelerators. We'll even split the model across multiple accelerators. And of course, we want to take advantage of existing libraries that can also help efficiently manage large model workloads. So in this case, we look to DeepSpeed and Optimum Habana to help manage these workloads and make training and inference easier for these large models. So to get started on the Gaudi accelerator, we look to 3 places that make it really easy to get started. First, we have the model references GitHub page. And so this includes a full set of fully validated and documented models that make it really easy to run. And these include computer vision, generative AI, and large language models. And there's over 40 models there and growing every day. Where we'll focus in this video is in the middle section using Hugging Face. So we've partnered with Hugging Face to create the Optimum Habana library. And this includes fully optimized and documented models and task examples that make it really easy to run models using Hugging Face transformers. And finally, for those that are bringing their own models running previously on a GPU, we offer the GPU Migration Toolkit, which makes it very easy to migrate a model that previously was running on a GPU, to change some of those instructions that were running previously on GPU into something that Gaudi can understand. So it allows you to bring models from a GPU and very easily get them running quickly on Gaudi. In this video today, we'll focus on this middle section, Hugging Face. So first, what is Hugging Face? Well, Hugging Face is one of the world's largest open source repositories of transformer and diffusion-based models that support generative AI, large language models, and many other tasks. So if you look to the right here in this picture, you'll see many examples of tasks that are supported by Hugging Face models. This includes both training and inference. And we have the Optimum Habana library used for Gaudi to support many of, if not all of these tasks. So the Optimum Habana library allows Hugging Face transformers and diffuser models to run on the Gaudi AI accelerator. So you can think of it like a bridge between all of those models in the Hugging Face universe and Gaudi. So this replaces the generic Hugging Face code with specific Gaudi configurations and pre-configured for use on many, many tasks. So we have a list of optimized models that don't need any configuration or modification at all. They'll run for you right out of the box. Now, in this case, you'll see here in the picture at the bottom, you'll see changing from trainer and training arguments to Gaudi trainer and Gaudi training arguments. So it's a very specific thing with some Gaudi specific information and optimizations. So now let's look a little bit closer at the Optimum Habana library itself. On the right, you'll see the set of optimized tasks. So again, if you're looking to do image classification, language modeling, text generation, or any of these lists, you can pair them with some of these optimized models on the left or your own model. So in this case, as an example, this allows you to mix and match our optimized models with the tasks from the Hugging Face examples. So if you wanted to do language modeling, you can use GPT or Llama 2 70 billion. If you wanted to do text generation, you can use Llama 2 or Bloom 175 billion parameter models. So we support the world's largest models. So speech recognition, translation, of course, stable diffusion. So again, you have the opportunity to run these models right out of the box with fully documented and fully optimized models that are important in the model ecosystem today. So now you want to run these, how do we run them? 3 simple steps are required to run Hugging Face models. First, we want to install the Optimum Habana library. So we have a stable version available on PyPy, so it's a very simple pip install command to load the Optimum Habana library. Second, we'll load the repository of examples that I've showed you from the previous page. And then you'll go into those Optimum Habana examples and select the one you want to use. And then once you're in that example, then you'll have a full list of documented instructions to run and execute any one of the models. So let's go look at a couple of those run commands. So on this page, you'll see 2 examples here. On the left, you see an example for inference, and on the right, you see an example of training using 8 cards in deep speed. So in this case, there are some calls here that we need to talk about and make sure that we're clear on. First is Gaudi spawn. You'll see that here at the top of the run command. Gaudi spawn is an application, a small application that's used to manage multiple card and multiple node execution. Second, calling out the use deep speed command. So if we are using deep speed, then we need to make sure that we have the use deep speed command called and a path to the deep speed configuration file. Use Habana is telling the model that you're going to run the training or inference on the Gaudi accelerator. Using HPU graphs will tell us that we are using a performance enhancement here called HPU graphs, which helps prevent recompilations. Using KV cache is another performance enhancement, which takes advantage of some of the static shapes that we've set in some of the models. So in many cases, models that have dynamic shapes can cause recompilations and impact performance. In this case, many of the models, we've enabled them to run with static shapes, and using KV cache is a part of supporting static shapes. And finally, setting bfloat 16 is important because we want to make sure that we're running at bfloat 16 instead of floating point 32 for improved performance. And you could see a couple of these examples used here throughout the model runs. And again, you can consult the README for each model for some specific details on how to run them. So now let's look at a real example using summarization. So now in this case, we'll start at the top. And we are going to, this is a Jupyter notebook running on the Intel Developer Cloud with access to 8 Gaudi 2 accelerators. And so in this case, we're going to use the summarization task in HuggingFace using the model called T5. So let's go through the steps. So first, we set up the Gaudi PyTorch Docker image and run this notebook. So right now we're running on the PyTorch Docker. So we have the entire Synapse AI software stack included, and this notebook is running on top of that. So the first step is to install DeepSpeed. So we'll install the DeepSpeed library, and that's already been done. We'll install the Optimum Habana library, which we showed in the steps above. That's completed. Then we'll install the HuggingFace Optimum Habana model repository. So we now have all of those examples and tasks that we talked about earlier, and we're going to go to the summarization task. So we'll go into the location in the examples and pick summarization. Next, we'll install the specific requirements for summarization, and then we're ready to start running the model. Now, since this is an 8-card model and potentially we can use the full 11 billion parameter model, we want to set up DeepSpeed here to manage that large language model. And there are some steps here to make sure that we're running that properly. We want to make sure that we see the DeepSpeed initialize, the DeepSpeed init distributed, and create the DeepSpeed config JSON file to set the DeepSpeed training parameters. So we can find those first in deepspeed.py. We'll see the DeepSpeed initialize command. And then in the training arguments.py, we see the DeepSpeed init distributed command. And then finally, we need to create the DeepSpeed config file. And so in this case, we're going to push this content here into DeepSpeed config.json. And a couple key points here are first, running bfloat16 and setting the 0 optimization stage to stage 2. We're using 0.2. We have another video that goes into some detail about the usage of DeepSpeed. So if you're interested in more details, you can check that video out. Okay, so we set that DeepSpeed config, and now we look into the fine-tuning. So we're going to take this model, and we're going to fine-tune it with the CNN Daily Mail dataset. And so we remember that we have GaudiSpawn.py running and calling the run summarization model. Now in this case, for this simple example, instead of using the full 3 billion or 11 billion parameter model, we're going to use the small version. So this, instead of being T5 11B, we're going to use T5 small. And as I mentioned earlier, you'll see those same prompts using Habana, using HPU graphs, and making sure that the execution of this fine-tuning is running on Gaudi. So we kick this off. And again, this takes about 32 minutes to run. So this has already been run previously. And you'll see all these examples of the model being set up. You'll see the data being downloaded in this case, the model being downloaded and prepared. And you'll see the PyTorch bridge configuration, letting you know that this is actually being run on Gaudi. And then other setup information until we get to the point here where we start running the actual training. So you'll see as we go through each of these cases, you'll see the learning rate, the epoch, and the measured loss. And we want to see this measured loss continue to decrease as we fine-tune the model. And so finally, at the end of the 3 epochs, we see the training is completed. So we see that we've run 3 epochs, and this runtime took about 32 minutes. So now we have a full set of models, or a full model that we've fine-tuned. So that was in the FT summarization folder. And when we look inside that folder, we see the checkpoints, and we see PyTorch model.bin. So this is now the model that has been fine-tuned and that we'll use for inference. So now that the fine-tuning is completed, let's shift over to running the inference. And you'll see this command here. We'll set the model to fine-tune. And again, for this demo, we're going to use T5 small. We set our model. We set our tokenizer. and we set the path to the actual local model, which was pointing exactly to this location here. So it is in this FT summarization folder. So now to run the summarization and run the inference, we set up a HuggingFace pipeline, which is the task of summarization. And that model is pointing to our local model. And the device here is pointing to Gaudi. And we pick a very long set of text to summarize. In this case, this is a very long text about nuclear proliferation. So now we'll run this live. And so we know the act of summarization here is taking a very long, large piece of text and being able to make a summary of this text. And again, now we're running inference. And so we see again the PyTorch bridge showing up, telling us that this is running on Gaudi 2. Okay, so we'll wait just another moment for this to complete. And there, now you see a very nice summary of this long piece of text, now summarized very nice into a very concise summary. Okay, so now that we've seen that demo, let's close and talk about how we can actually access some of the collateral. So a couple of key things here. First, our developer page. This is the main place to start to get access to our performance numbers, our catalog, tutorials, and documentation. You can go straight to docs.habana.ai for detailed documentation. Our forum and service desk here for interaction with the larger ecosystem and community. And finally, our GitHub page. So all of the notebook you saw here and all the models we've talked about in this video are all available here on GitHub. And to actually run on Gaudi 2, we recommend that you use the Intel Developer Cloud. The Intel Developer Cloud gives you hourly access to 8 Gaudi 2s. So it's a very low cost way to get started accessing Gaudi 2 on a per hour basis at a very competitive cost. So in summary, we've shown you how to use HuggingFace with the Optimum Habana library to get started very quickly and easy running models, running large language models and generative AI models on the Gaudi AI accelerator. Thanks for watching.